Hello and welcome to the first part of the series. We are going to be making an automated gardening system using Arduino Uno R3. I personally am going to be using an Elegoo as Arduino actually has all of their plans online and anyone can go and look them up, manufacture, make their own, whatever you want to do. It's all open source. So I'm going to use Elegoo because it's less than half the price. But if you want to actually use the Arduino as it is, you can go ahead and do that. So if you don't have a Tinkercad account, I recommend you go ahead and make one. I'm just going to show you this because it's easier to explain and see everything. And then later in the series, we'll actually go ahead and build it and put it in the physical world. So first, make your Tinkercad account, and then we're going to hit create and create a circuit. If you want to see that actual part, I'll click back to this. You can create your own design and circuit, right? So I'm just going to go ahead and click automated gardening board and then tinker this. And that takes me to my blank canvas that I already set up. So the only board that they actually have in this is the Arduino Uno R3, as far as I know at least. They might have more, but on the main page there. So this is what it looks like. We have our power section, which goes ground, 5 volts, 3.3 volts, resetting the board, etc. Analog in, these are your analog inputs. You can also change them to outputs as well. We'll go over that later. And then we have our digital. So we have our receiving, transmitting, 2, modulating, 3. That's the symbol here of little tilde, I think it's called. And it goes all the way up to 13, then another ground. Okay, so just a basic overview of the board for what we're going to need out of it. Next, we are going to add a soil moisture sensor, as that is our first kind of thing that we really need to actually build in this. So we're going to go ahead and put that in. So we have where our power needs to connect, our VCC. Our ground needs to connect, that'd be the GND, and then our signal is the SIG part, right? So our power to actually power the device, our ground to keep it grounded and complete the circuit, and then our signal is going to go into our analog and tell us exactly how moist the soil is, so we know whether to water it or not water it. So for the purposes of this is a 5.5 volt. You can go ahead and just click that little box right there, that pin, and then anywhere you click, it is going to draw. So I'm going to go ahead and click and then go down to VCC power, click in there, and it ends that little power line there. So next, we need to ground the device. So I'm going to go ahead and click there, click over here, drag it all the way over here to the ground, and click in there. Okay. So we have our power, we have our ground, now we just need our signal. We're going to go ahead and drag that over as well, and I'm going to put that in A1, okay, because we're going to use more than one moisture sensor eventually. So A1 through 4, we're going to call it, and that's going to be our sensors. So now we are all wired up. So I'm going to go ahead over here and click code. Okay, now you can use blocks like this, and it would look just like kind of an entry-level kids programming language, or you can click text, continue, and come on over to the big boy language of C++. Now, I primarily code in Python, so you will see me forget a lot of the time to put the semicolon on the end. I do that quite often. So I'm going to get rid of this code that does not need to be here. We did not write it, so don't need it yet. And I'm going to start in our setup. So first thing we're going to put is serial.begin, lowercase begin. This will begin our serial monitor at the bottom. 600 and end that line. Okay. Next, it's best practice to set your pin modes. So I'm going to do a pin mode, and then I have to specify the pin, and then if it's going to be an input or an output. So the pin that we are in is A1. So you can simply come over here and put A1. That's it. And then we're going to go to our loop. Now our loop is going to go through all of, well, actually, hold on one second. We want to do a delay after the setup to give stuff time to actually um, start working and get power. So our loop begins. So now we want to read the device and we want to print it out. So I'm going to first make an integer, as the soil moisture sensor gives us integer values back. And I'm going to call this sensor value 1. Okay, and that's going to be equal to analog read of the value. So that's going to be A1. Okay, now if we want to keep the code nice and clean and easy to edit in the future, we can put the sensor key, we'll call it, sensor key 1, because it's the first one. And we can go ahead and put it in there. So instead of putting A1 here and there, we can put it there. And this one is going to be a constant, and it's going to be a character, because it's not just a number, it's a character value. So now I'll copy this, paste it where the two places we have A1, so we can just change that in one spot rather than multiple. So we have the sensor value, but we're not printing it. So we need serial print ln, and I'm going to go ahead and print sensor value 1. Okay, so I'm going to go ahead and hit start, and we have our first error. So in the void loop, we are expecting a comma or semicolon before serial. So before this line 17, I forgot to put semicolons on those. So that's going to be the error. You can see line 17, it also pops up there. Okay, so let's try that again. And it seems to have no bugs. Now let's go into the serial monitor. We can see it's popping up 0, 0, 0, 0, 0 every second. So you're probably thinking right now, well, is it working? We have to go and click on this and then change the actual water level of the sensor, right? So we can see about halfway through is about 500. And if we go to all the way wet, we're getting 876, okay? So top of the line is 876, and no water would be 0. Okay, so we will keep that in mind for later. I'm going to go ahead and put it as a comment. Oh, sorry, you cannot code while you're in the simulation. So wet is 876, dry is 0. Okay, so when we're going to actually water our plants later, we need to keep those in mind. Okay, so if this is plugged into the 5 volts, though, we are always powering this sensor. So if you're trying to preserve electricity or something like that, you don't really want to plug in the 5 volts. You'd want to use something like a relay. So obviously, we don't have any relays. This is just going to be powered on reading the entire time. But for the purposes, we're going to go ahead and make a relay. Next, we actually need to use a relay. And this one is the easiest one to actually fully understand. So we have our coil here, which opens and closes this gate. So terminal 5 and terminal 8 are going to be connected, one with the positive side and the other with the negative, and that's going to complete that circuit through there. This side is going to be whatever power you want to supply to the other end here when you want to switch it on or off, and that is going to give us our power. So if you can see, there's only one 5 volt here, and we're currently using it. So what we need to do is grab a breadboard. So I'm just going to go ahead and grab this breadboard small. I'm going to delete this connection here. And I'm also going to delete this ground connection here. A1 can stay because there's really no purpose to putting it on the breadboard and then to there unless we're going to use it for another signal in, but that would just confuse the hell out of this thing. So no real purpose on doing that. So I'm going to go ahead and take this 5 volt. I'm going to bring it all the way over to the positive here. That's going to be our input and our ground over here to the negative. Then I'm going to take this positive over here, bring it over there, and this negative and bring it over there. So either side of the board, this is now ground and this is 5 volts. Okay, I could also change it so that this side is 3.3 volts, but pretty much everything in this is going to be 5 volts. So we're just going to keep using that. We are about halfway done. Okay, so now I need to repower and ground this. So I'm going to bring this over and put it on the negative for the ground, and the power is going to go onto the positive. Okay, so we can still clearly see for now exactly what's going on. So next is going to be this relay, which we are going to use to power a motor. So what we're going to want to do is detect if the thing needs to be watered, and if it does, we want to turn this relay on, or essentially the normally open is going to be closed to allow the circuit to go through. And we want that to then switch on the motor that we're going to use for this purpose. I'm just going to use this DC motor as we don't really have a pump. I don't believe in this. I can search all pump. No water pumps. Okay, a motor and a pump are pretty similar. So we are then going to wire this up. So as I said before, we're going to need one of these pins to go ahead and go in. I'm going to take pin 2, drop it down here, and bada bing, bada boom, that's in. And then this side has to go to the ground. Okay, so that one's grounded. Okay, so that completes that circuit. Now we have to complete the other circuit. So terminal 1 is going to go to 5 volts. So we're going to take that over, put it on the positive here, keep it nice and square. And that is 5 volts in. Now the other side, this side, if there's no power coming from 2, is going to be a completed circuit. As we can see, it's touching, right? That means that it's going to transmit electricity. When we do the actual video in real life, you will hear the click of the open and close of that gate. So we want the one that's not usually touching, terminal 6. We're going to bring that over to our positive end, as that is the input. Okay, so next we need to take this and bring it to the ground again. And go ahead and put it on that one. So I know this is a little harder to read now. This one is a complete line from positive to positive. This one's just going to that ground. Okay, so if I hit start on this, I'm going to say this one's going to be 2, high, 2 is output. Okay, so we have our sensor being red. We have our codes of wet and dry, and we have our pump over here. Okay, so right now it's going to do digital write to no matter what. So let's go ahead and start that. And you can see our motor is indeed running. Our serial monitor is 0 because we didn't set this to have a moisture. But we can change that, right? That now has moisture. If I wanted to stop this, right, and change this guy over to the other terminal that's normally closed and hit start, we're still running for some... Never mind, we're not running. 0 RPM. I was right. Okay. I don't know why it lagged. Okay, so now, because this is powered on, oh, that's probably why, because it was powered on and that was taking time to get the device. So this is no longer connected. You can see the gate is now up, so it needs to be up there. So I'm going to hit stop simulation. See the gate's now down. I didn't know that updated. That's quite cool. Okay, so there's no power. It's going down. So now we need some sort of logic to say when this is wet, go ahead and turn on our pump. Okay, so this is going to be as simple as an if statement. If, and we're going to say some value of wet. So pretend your plants like to be wet all the time. So if our sensor one value, sensor value one, and the more wet is the higher value. So we want to do is less than, because that's more dry. And we're going to do less than 200. Okay, you can choose what you'd actually like to put there later. Close that. Enter, tab. Okay. Then we would want to go ahead and put the pump on high. Now, if we go ahead and do this, we're setting the pump to high, but then we're never turning it back off ever again. Okay, so what we want to do is add in another delay. Okay, and that delay is going to go right here, and maybe we want 5 seconds of pumping. And then we want to go ahead and turn this off, right? Well, let me put this in that loop. That makes the most sense. Then we're going to say digital write to low. Okay, and that's going to put it to 0. So we're going to turn on the pump for 5 seconds. We're going to keep that pump on, and then we're going to turn it back off. It's going to wait another second and then go back. So what we should see here first is this soil moisture it's going to be at 0. So it's going to be as dry as it could possibly be. This gate will flip up. It'll turn on the pump for 5 seconds, and then the pump will turn off. And then it's going to reinitialize the loop. Okay, so I'm going to wait another 5 seconds. I'll wait 3 seconds here. Okay, so it'll turn off for 3 seconds and I'll rerun the loop. Because this pump is not actually pumping any water into the sensor, we'll have to actually change that and move it ourselves. It won't be enough to actually wet it and set it off itself and be fully automated. But here we go. Let's see what happens. So we can see this is 0. This turns on. There's 5 seconds, and now it's going to wait. But because this is still 0, as you can see here, it turns back on again. So if we're like, oh, now it's watered, we're at 280 now, and we're saying if it's below 200, turn back on, this will now stay off, right? So it's going to stay off until it reads it again. Now, if you wanted to, you could put this on a relay as well and say, okay, I only want you to read this every 10 minutes and try and preserve some battery. Or you could just leave it like that. That's what I'm doing. And yeah, that's about it. So our next part is if we want any sort of indicator that a pump is running, like a light indicator or a screen, if you want to read temperature, humidity, anything like that, we want some sort of indicator that this is indeed on, or I guess this pump is on. So I'm going to hit stop simulation, and let's go grab an LED. LED, there we are. Okay, so this LED just goes into the breadboard like that. Now, the way the breadboards work is all of these pins are connected. You can see when it turns green and they're all highlighted, all of these pins are connected. And then when you go into the actual breadboard, they're connected sideways, but not touching. So this end of the LED is one, and this end of the LED is the other. So this one is going to go into the positive and this one into the negative. So I'm going to say this is a red LED. So when this is on, that means that we are not pumping. So red, stop. That's just what I'm going for. Green will mean pump. So when this one is connected here, that means we are pumping. Okay. So the other way that we could possibly do this is take this, bring it over here. It's kind of hard to see. I'll put it over there. And that's going to power the LED when this is on. Okay, or yeah, when it's on. So let's change this to green. And that's also going to power that gate still, so I need to bring that back over. Okay, so when this is on, it'll go there. Now we need to connect this end to the ground. So let's go ahead and start the simulation, see if that works. And it's not lighting up. There's no light to the LED. Let's see if the pump is working. Yep, the pump is working, but we don't have an LED. So why would that be? Well, I know exactly why that would be. Because you need to use a resistor. The resistor for the LED is about 220 resistance, 20 ohms. We're going to go ahead and put that there. And oops. Oh, I guess just there. Okay. And that'll bring us to our ground. So it's going in, out here, and then over to the ground. Let's start it up again, see if it works. Now it's not working. Why is that not working? Well, let's change these around and see what happens. LED, LED. Green. Anode is going to go to this side now. Cathode go to this side. And now it's lighting up. All right, so I had the anode is the inside for the positive and cathode for the negative. I just had that mixed up. Sorry about that. So I guess I'll think of it now as alphabetical, of A for in, because you go in before you go out, and C is after A in the alphabet. Okay, so anode, anode positive, cathode negative. Okay, so you can see when this turns on, this is spinning, pumping our water, our imaginary water in this case, and we have completed our circuit. Okay, so now if you wanted to, you can just add one more motors and more sensors and pump into other pieces of the garden. So for the next stage of this presentation here, I'm going to show you how to actually install everything on your desktop and get the code going, plug in your Arduino, and then we can kind of get going on how to actually make this in real life. So stick around. Thanks for watching.